Okay, folks, let's talk about the main idea of this section of this lesson. The main new idea is looking at the graphs of the trig functions, starting with the graphs of the basic trig functions, sine, cosine, and tangent, and then looking at what happens when we modify them in various ways. And in this video, we are going to be looking in particular at the graphs of, oops, my pencil, of sine x, cosine x, and tangent x. And we're going to be considering the following. If we look at these as functions, what is the domain of each function? What is the range of each function? And then what is what we call the period of each function? That has to do with how long does it take for the function to repeat. We'll get to that in just a second. So that's the basic idea. Three functions and then three different characteristics of each one. Okay, in order to look at these, let's go ahead and pop over to Desmos. So here I've set Desmos up. Let me turn my pointer on. There we go, so I can look at things there. And if we turn on the sine function, if you remember moving around the unit circle, the sine is like the y coordinate on the unit circle, which means that when the angle is 0, the y coordinate is 0. So the sine function, you'll see that's reflected here. Here the x-axis is the angle, and the y-axis is what is sine equal to. So when the angle is 0, sine is equal to 0. When the angle grows to pi over 2, that's like a 90-degree angle, the sine has risen up to a height of 1. As the angle progresses to pi, or 180 degrees, the sine falls back to 0. And then as the angle continues, the sine goes down to negative values, down to -1. It reaches -1 at an angle of 3 pi over 2. That's in a unit circle. That's the point at the very bottom of the unit circle. And then finally, as the angle continues back up to 2 pi or 360 degrees, that's like we've come all the way around the circle once, and now sine is equal to 0 again. And then the whole thing repeats. So a couple of observations about this. First of all, what is the domain of this thing? Well, the domain, it keeps going in both directions. So the domain is all real numbers. And we could denote that for sine, the domain is all real numbers. We could write that as the blackboard bold R. We could also, if I give myself a little bit of a smaller pen, we could call that minus infinity to infinity. That's the domain of the sine function. That's because it goes all the way to the left and the right. Now, the range of the sine function is different. If we think about along the y-axis, that's like the range, what's the highest this function goes and the lowest this function goes? Well, the highest peak is here, and that is at a height of 1. And the lowest peak valley is down here, and that is at a height of -1. So the y values all go between 1 and -1, and that means that the range of this function is from -1 to 1, and I'm using square brackets there because it actually reaches -1, and it actually reaches 1. So those are included in the range. You can see that it reaches 1 here at an angle of pi over 2 or 90 degrees, sine is 1. And here at an angle of 3 pi over 2 or 270 degrees, the sine of that angle is -1. So domain is everything, and the range is only between positive and -1 on the y-axis. And then the last thing you notice is that if you follow the sine function starting here, it goes up and then down and then back to 0 again. And then from this point, it's just like it starts over again, doing just exactly what it did here, first going up again, up and then down. If we scoot ourselves over, we can see it goes from here up and then down. That's like its second complete cycle. And it goes again up and then down, and that's its third complete cycle. And the distance it takes for one entire cycle is called the period of the function. So sine is what we call a periodic function. That means that as you progress along the x-axis, it repeats itself, and the period is just how far do you have to go before it starts repeating. And if we look back at the origin at 0, 0, here, the distance it goes is from there to there. The x value here is 2 pi. So this thing has a period of 2 pi. And if you think about the unit circle, 2 pi is the angle you reach when you've gone all the way around the circle once, and then you're just ready to go around again. And so from there on, you can sort of see it's going to repeat. This has a period of 2 pi. Let's go ahead and put that into our notes. Period is 2 pi for the sine function. Okay, let's take a look at the cosine function with the same ideas in mind. For the cosine function, if we turn it on, this one appears in purple. If you remember, cosine on the unit circle, cosine is like the x-coordinate, and that means that when the angle is 0, the x-coordinate on the unit circle is equal to 1. And that is why here, if this is the angle, then that cosine has a value of 1. It's important to note that in this picture, the x is like the angle, and the y is like the value of the function, sine or cosine or whatever. And you have to think separately of a unit circle picture if you want to think in terms of those x and y coordinates being cosine and sine. Okay, so it's when very often, I think many mathematicians, when they look at a picture of sine and cosine, they have a separate picture in their heads, which is a picture of a unit circle and a little point moving around that unit circle. And that sort of lines up with the way that these guys move as we move along the x-axis here. Okay. Once again, the cosine function, it goes to the left and to the right everywhere. Let's turn off sine, it's a little distracting. This is just the cosine function, and the domain is everything. And the range is, once again, the highest point it reaches is 1, and the lowest point it reaches is -1. And it actually not just reaches, but it actually achieves is equal to 1 here, and to -1 here, 1 here, and so on. And because of that, the range includes the points -1 and 1. So we're going to see that we get the same answers for the domain, -infinity, infinity, or r. That's the domain of the cosine function, and the range of the cosine function is also -1, 1. Now, with regards to the period, how long does it take to repeat? Well, if we start here, it's up at its highest point, 1. How far does it take to get back to the highest point? Well, once again, the x value here is 2 pi is what we get. And so it's a period of 2 pi. Then it starts repeating again, down and then up, and so on. And you'll see that it just continues repeating as we go to the right. And the distance from, say, one point to the corresponding point here, that is always a distance of going to be a distance of 2 pi from one to the next. So the period of this function is 2 pi. Okay. Now, for the tangent function, we've looked at the values of those in a table, but it also helps to think of tangent as what you get is when you divide sine by cosine. It's sine over cosine. And when we look at this in Desmos, if we look at sine and cosine, sine is the green one, cosine is the purple one, and tangent is sine divided by cosine. So if we try to think about various points here, let me just go collect my pointer. There we go. When when the angle is 0, we have sine is 0 and cosine is 1. So the fraction sine over cosine is 0 over 1. 0 over 1, that fraction is a perfectly fine fraction, is equal to 0. So what is tangent equal to here is equal to sine over cosine, and that means it's equal to 0. Tangent is of the angle 0 is going to be 0. And then the trouble is going to come. The interesting thing about tangent is that since we're looking at sine over cosine, it's like, think of a fraction where the number given by the green line is on top and by the purple line is on the bottom. As that number on the bottom gets closer and closer to 0, you're going to have a number on top divided by something very, very small. And that makes the fraction equal to a very large number. And when we hit this point here, pi over 2 or 90 degrees, the tangent there is somehow equal to sine over cosine. It's 1 on top of the fraction and 0 on the bottom of the fraction. And 1 over 0 is undefined. We cannot have a fraction with 0 on the bottom. And that tells you that there's going to be something weird going on at this angle, 90 degrees or pi over 2, for the tangent function. The tangent function is not going to be defined here. Let's look at what the tangent looks like. Okay, here's the tangent function, and you'll see that at the angle 0, the tangent is indeed equal to 0, and as the angle increases towards pi over 2, the tangent gets bigger and bigger and bigger and bigger and bigger, and it has a vertical asymptote here at pi over 2. And when you cross over that pi over 2, just past it, the tangent function is very, very negative, and that's because it's sine over cosine. Sine is a positive number, and cosine here is a negative number, and it's a very, very, very tiny negative number. So a positive over a very small negative, the answer is going to be negative, and it's going to be a big negative number, which is why you see this going so far down below, down here. So this is somehow why the tangent function is undefined here. That's like when you get 0 in the denominator, it's not equal to anything. Just to the left of that, it's a very big positive number. Just to the right of that, it's a very big negative number. And then tangent, it increases until here at pi, that's like 180 degrees. We're looking again at sine over cosine. Sine is the green one, sine is 0, cosine is the purple one, cosine is 1, and the fraction 0 over 1 is equal to 0. That's why tangent is 0. And then as we progress again, the tangent continues, it rises here, and it's going to have a problem again at this angle, 3 pi over 2, which is like the angle 270. It's the angle at the very bottom of the unit circle. And here, tangent is once again undefined because we have a fraction, sine over cosine, and the cosine is 0. You can't have a fraction with 0 on the bottom, and that's why we get this vertical asymptote right here at 3 pi over 2. We're going to get another vertical asymptote. In fact, what you see is that the tangent consists of this arc like this. It's shaped a little bit like an x cubed graph, except that it has asymptotes here and here instead of going up forever. And that shape repeats itself. It goes between... let me see. Look, it looks like here it goes from minus pi over 2 to pi over 2. And then it repeats itself again from pi over 2 to 3 pi over 2. Repeats itself again from 3 pi over 2 to 5 pi over 2, and so on. So if we take away sine and cosine, we see only the tangent graph. Now, a couple of observations about this. First of all, what is the domain of this function? Well, it goes sort of all the way to the left and right, but it has these holes. It has a hole at minus pi over 2. It has a hole at pi over 2. It has a hole at 3 pi over 2, and so on. And so what do we get? We get this interval from minus pi over 2 to pi over 2. We get an interval from pi over 2 to 3 pi over 2, but it doesn't include this pi over 2 right here. So the domain is more complicated for the tangent function. The domain really consists of all of the numbers where the cosine is not 0, because cosine is 0. Those are exactly the places where you get 0 in the denominator of the tangent function. Okay, so collecting this, what do we see? Well, the tangent of x is the following. There's different ways of writing it. One is to go dot, 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 and then write each of the intervals. The first interval I think we looked at was from negative pi over 2 to pi over 2. And then union from pi over 2 to 3 pi over 2. And then a union, let me make it even, zoom in even farther. Union from 3 pi over 2 to 5 pi over 2. And then union dot, dot, dot. The trouble is that there's infinitely many of these guys, so they go on forever. That one is a little bit difficult to write out, but that's the domain. Another way of writing the domain is to say R and then use the minus, and then put the set of all the numbers which are bad. The bad numbers, the numbers that don't work, are the ones where cosine is equal to 0, and they include the numbers pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, and dot, 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 and of course they go in the negative direction too. There are various other ways of writing the domain of this, but the key idea for tangent is simply that it has these problem places in it. It has these places, exactly the places where the cosine function is equal to 0, these places, and those are not part of the domain. But all of the other things, the things in between those places, are in the domain of the tangent function. Now, the range of the tangent function is also a bit strange, a bit different than sine and cosine, because the tangent function extends all the way up and all the way down. So if you think about the y-axis, the tangent function goes all the way up towards infinity and all the way down towards negative infinity, which means that the range of the tangent function is all the real numbers, or from minus infinity to infinity. Let's go ahead and record that one as well. I'm sorry, I've bumped up against myself here, but the range, I'll change the color to make it really clear that we're moving to discuss range here. The range of the tangent function is from minus infinity to infinity, or another way to say that is it's all real numbers R. So that's the range. Now the period, you might think that the period is just 2 pi. That sort of makes sense, but if we look carefully at the graph, we'll see that the place that it starts to repeat, if we start at 0, the tangent is equal to 0. There it crosses the x-axis. And the next place where it crosses the x-axis is at pi. And this piece here looks just like this piece here. So it's starting to repeat. At first it goes up, then it has a place where there's a asymptote, and then it goes from the bottom down up, and then back up to 0 again, and then it starts to repeat. So to get from 0 to where it repeats, we only go a distance of pi. From here to where it repeats again, it's a distance of pi. If you prefer, you can go from, say, where the asymptote is at negative pi over 2 up to where the next asymptote is at pi over 2, and that distance is also a distance of pi, because it's negative pi over 2 there and pi over 2 there. Put those together and you get pi altogether. From here up to here is a distance of pi. That is, from pi over 2 up to 3 pi over 2, if you look at how far it is from one to the other, is a distance of pi. So the period of the tangent function is simply pi. It has a shorter period. The period is half as much as the period of the sine and the cosine functions. So what are the takeaways from this? Sine and cosine are quite similar to each other. They just start in slightly different places. They're sort of shifted one off from the other a little bit. Tangent is very different looking. It has all of these asymptotes, these places where it's not defined, and the range goes all the way up and down on the whole axis. Sine and cosine repeat after 2 pi, but tangent repeats just after pi. Okay, that's our introduction to the basic trig functions. In the next video, we'll look at what happens when we start to modify these functions.